Welcome to part 3 of the Side Object tutorial series. In part 1 and 2, we looked at the Mesh object and the Procedural Mesh object side object type. Both types will generate the side object based on a prefab modeled outside of Unity. The Mesh object side object will spawn the prefab along the spline path. The Procedural Mesh object will extract the mesh data and regenerate it smoothly, exactly following the spline path. If you missed these tutorials, direct links are included below in the description. The first video also includes an introduction to the Side Object Manager where we can create and edit side object presets. Today, we are going to cover the shape type of side object. So for this video, let's jump straight in and create a new side object. We name it Shape Object Example and select the shape object type of side object. This shape type of side object generates the object along the spline path according to a specific shape. Shape type of side objects are useful for scene objects with a shape with no additional detail in the repeated sections, like basic wall shapes and terrain deformation objects like riverbeds or road shoulders, optionally snapping to the terrain on the outer side of the shape. But it can also be used to create shapes like tubes or pipelines. No need to model them outside of Unity. We can define the shape right here in the Side Object Manager. We will look at that in a minute. Let's first have a look at the inspector options. First, we have the same standard Unity game object options we also had for the Mesh object and the Procedural Mesh object side object types: layer, tag, and static. Here we have a scale option. Usually the shape will already have the correct scale, but this option can be used to quickly scale the shape up or down when that suits the scene better. We can set the objects to cast shadows. That speaks for itself. We also have the default active state for each marker option. We explained this in part 1. When active, the object will be generated along the full road by default, and optionally, it can be deactivated for specific marker sections. When this is inactive, the side object will not be generated at all initially. Instead, the side object will appear after activating it for specific markers. This state is useful when the side object is only active on a small number of marker sections. Just like with other side object types, we can set the category tab for this side object. We will create a random shape, so let's add this side object to the miscellaneous category tab. In fact, let's select the terrain category tab. It will show 2 additional options that are shape object specific. These 2 options: terrain deformation object. When this is active, the side object will be used as a terrain deformation shape. In build mode, the terrain will be adjusted according to the generated shape, and the shape itself will be hidden. This option is used for the riverbed deformation surface side object in the demo package to carve the riverbed into the terrain. So this terrain deformation object option turns this system into a more advanced custom terrain shaping tool. Besides riverbeds, think of, for example, ski pist or snowboard slopes, or terraced mountain hills. Terrain surface object. This is a more advanced option that we will be looking at in another tutorial. It can be used for terrain detail meshes next to the road. It will affect the default terrain deformation. Optionally, we can set a target object stored in the project folder. This target prefab will be instantiated, and the generated mesh will be added to the mesh filter component of this prefab. This is for more complex side objects when script components are involved or a specific material setup. In the demo package, it is used for the river surface side object example. The river scripts and materials are already part of the target prefab, and the generated river mesh is assigned to the mesh filter component. If no target object is set, a new game object will be created, and in that case, we can assign a material here. This example will just be a simple shape to show the options, so we will use a distinctive material that will clearly show the shape definition. Here we have options to add additional objects to the generated mesh. We can add objects at the start of each section, at each new vertex row based on the below geometry resolution, and at the end of the spline path. So these three options can be used to make the final side object look more detailed. For example, wall posts for simple walls generated as a shape side object. Next is the most important part, defining the shape. Here, we can open the shape editor window where we can set the shape. The shape is created here on the canvas, and on the left we have a range of options to manipulate the shape and control the end result in the scene. Let's first look at how we can create a shape. Navigation works as in similar windows discussed in previous tutorials about, for example, the Custom Connection Editor window and the UV Editor window. We can see the options here above. The R key will put the focus on the center of the canvas. The Z key will set the canvas zoom level so all nodes are visible. Press the left mouse button and drag to move the canvas. Use the scroll wheel or press Shift and one of the mouse buttons and move the mouse up or down to zoom the canvas. To create the shape, we add nodes by double-clicking on the canvas where the node should be added. At any time we can select a node and move it around. We can also set the exact position here in the additional node options that appear when a node is selected. The shape will be generated along the spline path. The center of the canvas represents the exact position on the spline path. Also note that in order to create a shape with the normals pointing upwards, we add nodes from left to right. When that is not the case, the normals will point downwards. This is something to check when the shape is not visible in the scene. In that case, we can easily solve this here with the Flip Normals option, which will reverse the node order. So we can double-click to add nodes. The nodes will connect. We can insert nodes at the mouse position by pressing the Control key and double-click. Selected nodes can be removed with the Delete key. All actions can be undone. We can select multiple nodes by pressing the Shift key and then select other nodes. The selected nodes can be moved or deleted. When pressing the Apply button, the changes will be saved. This will also update scene instances of this side object. Let's apply the changes and activate this side object on a road so we can see what we are doing. First, we will remove the lampposts and guardrails to create room for the shape. The shape is visible. We can move some nodes. Press Apply. The shape indeed updates. So that is how we can create the shape here on the canvas, all straightforward and easy. Let's have a look at the options here on the left. Trace Object. Here in the Side Object Manager, we saw that we can assign start and end connection objects. It is possible to reconstruct a shape matching the geometry of an object in the project folder. This can be useful when you work with start-end objects, and when you want the exact shape of these objects to continue on the actual side object. Think of racetrack curbs, like the example in the demo package. The start and end objects will be positioned at the exact start of the spline path. The shape of the curb at that point continues on the spline shape, so the shape will be traced on the x-axis at z position 0, looking for vertices at z equals 0, because that is where the start object will connect to the generated shape. The position where both shapes should match. Depending on how the model is imported, you may need to change the axis. You will see that after pressing the Trace Mesh button, which will be enabled when a trace object exists. When no shape is extracted, or when the shape is extracted from the wrong axis, you can try another axis. This will be necessary when the model is imported into Unity with additional rotations on one or more axes. We can see here that no node is selected. When a node is selected, more options will be available. We will see that in a minute. Close Geometry. This will connect the last node with the first node, useful for tube or cube rectangular types of shapes. Optionally, start end caps can be created when the shape has volume, which is the case for this shape. We can adjust the UVs here in the UV editor window. Clamp UVs. This will clamp the UVs to their original values. In a minute, when we will be looking at node-specific options, we will see that it is possible to snap nodes to the terrain, and it is also possible to change node positions per marker. These dynamic node positions will result in different distances between vertices. When UVs are clamped, these UV coordinates will not adapt to distance changes between vertices. As we can see here, when UVs are not clamped, we can also store the original UVs, the clamped UVs, in the UV4 coordinate set. This can be used in more advanced shaders, for example for masking purposes. UVs relative to terrain. This option is useful for terrain detail meshes when one or more terrain textures are used. By generating the UVs relative to the terrain, the side object will seamlessly blend with the terrain. This option is, for example, active for the tunnel floor dirt side object that is auto-generated as part of the rock tunnel example. The floor material matches the terrain texture that is baked in the terrain splat map to visualize the road shape. The tunnel floor dirt side object is generated along the tunnel to cover terrain holes at the start and end of the tunnel, and the gap on the roadsides inside the tunnel. Let's go back and select the shape object example we created. Blend terrain in UVs. This is a more advanced option. A little bit further in the video, we will see that we can assign vertex colors to each node. When this Blend Terrain in UVs option is active, the UVs will be calculated based on the vertex color alpha value. When 0, the UVs will be relative to the terrain. Otherwise, the UVs will be calculated relative to the spline path. We can use this in a shader as an alternative way to create bumpy roads or tracks. The bike track example in the v3.1 demo scene was done this way. The outer nodes snap to the terrain and blend with the terrain because the UV coordinates are calculated so that they match the terrain. For the center, the dirt path, the UVs are generated in the direction of the spline shape. Preserve node direction. As mentioned before, it is possible to snap nodes to the terrain. We will see how we can do that in a minute. If that is the case, this option, Preserve Node Direction, will be active. Instead of snapping the vertex downwards, it will snap the vertex to the terrain in the original node direction. For this node, this will be in this direction. This option is used on the retaining wall side object in the demo package. The terrain snap weight for the bottom node is set to 1, so the respective vertices will snap to the terrain. Preserve Node Direction is active, so the vertices will snap to the terrain in this direction. When the terrain is close to the road, the vertex will be here instead of here, the position that matches the straight line upwards, above the bottom node of the original shape defined here in the shape editor. Let's go back to the shape we created. Copy horizontally. Imagine a symmetrical, more complex shape. With this option being available, the shape only needs to be set for one side. Copy horizontally will mirror the shape and connect it to the original shape. Since there are two ends, you will be asked at which end the copied shape should connect. What happened is that the shape was mirrored on the y-axis. The original shape overlapped the y-axis. All nodes are mirrored, resulting in what is currently visible. Let's undo the last action and move the shape to the right so it will be mirrored completely to one side. As mentioned before, we can press the Shift key to select multiple nodes. copy horizontally will now copy the full shape, and we can still use the close geometry option when the mirrored shape should connect on both ends. We often use this for creating more complex shapes for bridges. These shapes are usually symmetrical on the left and right. Let's undo all of this. Mirror horizontally and mirror vertically will mirror the current shape in the respective direction. Flip normals. We already mentioned this. It will reverse the node order. As a result, the normals will point in the opposite direction. So this button can be used to quickly fix the situation where the normals point in the wrong direction. Generally, the normals should point upwards, which means, as mentioned before, the nodes should be added from the left to the right. Next are the UVs. UVs will be created based on the distances between nodes. We can manually adjust that in this window. Important here is that a material is assigned for the side object. If that is not the case, this button will be disabled. So here we can fine-tune the UVs. By default, the coordinates are calculated by distance between nodes. We can see that here, when nodes are moved, the UV positions auto-update. We can manually fine-tune the position by pressing a node and dragging it to the desired position. The checker pattern now clearly aligns with the vertices according to the node positions in the UV editor window. Let's continue with the node-specific settings. We already saw that we enter exact node positions here. Here we have the terrain snap weight option. 0 means no snapping. 1 means that vertices will snap to the terrain. Any value in between the two will lerp the vertex between the calculated position and the terrain according to the terrain snap weight value. We can use this, for example, for smooth riverbed creation. The outer nodes fully snap to the terrain. For the next nodes, the snap weight gradually decreases. This will result in a smooth riverbed. And as we saw here before, this terrain snap option is also used on the retaining wall example. Here we have the vertex color option. This can be set per node. The generated vertex data can be used in custom shaders. Hard edge. Hard edge will do exactly that. It will start a new normal group at that node, resulting in hard edges. We can see we have smooth shading at the moment. After pressing apply, the shape will update, and we indeed see hard edges now. That is what hard edge does. We already discussed these other options. So that is how we can define the default shape and control the behavior of the shape. Let's continue with the general control options for the shape type of side object. By default, the shape will be generated according to the resolution value. Just like with roads, the value represents the distance between vertex rows in units. The default value is 10. We can lower that value to add more detail. Alternatively, we can activate Clamp to Road Geometry. The shape will be generated according to the road vertex positions. This is useful for low poly scenes. See how the geometry of the shape side object now aligns with the road geometry. So this Clamp to Road Geometry option is useful for low poly scenes where the geometry of different objects should connect. Let's switch the shading mode back and continue with the other inspector options. Here we have similar options as what we also have for the mesh object and procedural mesh object side object types. We already discussed this in part 1 and 2, so see direct links below in the description. We can set the position relative to the road. And for this side object type, we also have the dual-sided options, so a single side object can be used on both sides of the road. we have options to move the shape more sideways and upwards. These same options are available for individual roads and individual markers, so you have full control over the shape. We have the same offset options to set default start and end offsets, which is customizable per side object section. The full shape can snap to the terrain, which is useful when the shape is located in an area where the terrain will be adjusted to the road. The shape will also update when switching to build mode. We also have the same alignment options for shape type of side objects. Generally, this is not required for shapes unless they directly interact and should be aligned with the road. For instance, the retaining wall and road shoulder side objects, which are also shape type of side object. Both the side objects have flat sections near and aligned with the road. You want to use the path normal option in these situations, so the generated shape exactly follows the road, also in tilted sections. Here is another example of a flat shape that should align with the road, and that includes possible random tilting, also when only very gentle tilting is involved. UV tiling. This is shape type of side object specific. It controls the UV distribution along the spline shape. Let's first select a texture with more definition, so the UV options in the inspector are better visualized. So we can control the tiling here in inspector. This can also be set in the material, but we find it easier to fine-tune this here in the inspector. Next is flip UVs. Flip UVs will flip the texture from left to right. We have to reselect the road first, so we can quickly refresh the side object. So flip UVs swaps the UVs from left to right. We can put that back and we will change the focus in the scene to the end of the road for the next option, clamp V. This can be used to control the coordinate distribution along the spline path and clamp it to the specified value at the end. When clamp UVs is off, the distribution will exactly match the distance. When this is active, it will clamp to the defined value. This used on the racetrack curb examples to force the curb to always end at a full red section. To achieve that, a value of 0.5 is used, halfway the texture where red ends. For this material, right after the first white block. Here, we have the same combine option as we also have for mesh and procedural side object types. It will combine individual sections along a spline path in a single mesh. Finally, we can add a mesh collider if necessary, and update active scene instances can be used to update the specific side object in the scene after changes here. That covers the side object manager. So the side object is by default generated according to the defined shape here in the side object manager. In the scene, however, we can adjust the shape per marker in two ways. We can do this through the default Unity Scale Tool option available here, or the R key. This is a global scale option per marker that affects all nodes. It makes, for example, adding variation to river widths very easy. We can also change the local position of each individual node. This feature is toggled on and off by pressing the B key. Make sure the scene view window has focus. We can now see all the nodes. They are selectable and can be moved. When pressing the Shift key and moving a node, the position of all nodes outside the selected node will be affected. And we can manually select multiple nodes by pressing the Shift key. We can also do this with multiple markers selected. The exact new local position can be entered here in the inspector, and we can reset the node position, reset all node positions for this marker, and we can adjust the transition shape. This second way to change the shape is more advanced and gives more control. So altogether, the shape type of side object is versatile and can be used in various ways. No need to model a prefab outside of Unity, and the shape can be manipulated along the spline path. Examples that can be reviewed in the demo package are the retaining wall, the river side objects, road shoulders, and the tunnel floor dirt side object. So that concludes part 3 of the side object tutorial about the shape type of side object. We will be back soon with part 4 about auto-generated side objects that will be generated based on rules on specific road sections, taking into account the road shape and the terrain profile in that area. Meanwhile, also for auto-generated side objects, the provided examples in the demo package can be reviewed, and the EasyRoads3D introduction tutorial also includes a brief introduction. See the link below in the description. For now, we hope you enjoyed watching this video, and we look forward to seeing you back in part 4. Be sure to subscribe to this channel and get notified when new videos are available. See you in the next video. Bye for now.